Oh, good morning. Well, I guess you're watching this afternoon, so I guess good afternoon to you. I'm making this in the morning. Today we are going to move on to chapter 2. Um, Along with watching this video, you will soon be getting a hard copy of your textbook. So these videos will be less and less because you'll actually have a textbook. But today we're going to walk you through section 2.1 where we're looking at pairs of angles. So when I have two lines that are cut by a transversal, so this image right here is showing lines that are cut by a transversal. And when I have lines that are cut by a transversal, I end up making pairs of angles. Okay. And the first pair we're going to talk about are corresponding angles. So if you're looking at these two lines cut by this transversal, you get corresponding angles. And corresponding angles, if you're looking at this image, so angle 5 and angle 1 are corresponding. Angle 6 and angle 2 are corresponding. It means they're at the same spots of the transversal and the intersecting line. So you see how angle 6 is right here on the interior of this line and this transversal, and angle 2 is right here, same spot but a different line but the same transversal. So corresponding angles are in the same spot on the transversal but on the different line. Okay. Alternate exterior angles are exactly how they sound. They're on the exterior of my two lines. So angle 5 and angle 3 are alternate exterior angles, and angle 2 and angle 8 are alternate exterior angles. They are on the outside of the two lines, and they're on opposite sides, hence the name alternate, of the transversal. So they're on opposite sides of the transversal. Alternate interior angles are on the interior of my two lines, and again they're still on alternating sides of the transversal. So angle 6 and angle 4 are alternate interior angles, and angle 1 and angle 7 are alternate interior angles. So these are pairs of angles. Now, why are these important? Well, these are important because there are theorems with these pairs of angles. If my two lines here are parallel, so if I have two parallel lines cut by a transversal, then we start getting congruent angles. So our first postulate is the same side interior angles. If a transversal intersects two parallel lines, so these two lines are parallel. If a transversal intersects them, that means the same side interior angles are supplementary. Okay, and you can see it with this image. No matter how I put the image, the same side interior angles are supplementary, meaning that these two angles add up to 180 degrees. This is the same side interior postulate. Okay, this only works if I have a transversal cutting two parallel lines. If my lines aren't parallel, this postulate is not true. Okay. So it says here as an example, here is two parallel lines. So you see this little arrow here? These two little arrows are showing that these two lines are parallel. That's notation. It says how can you express each of the ordered angles in terms of x? So if this is x, okay, well, let's talk about angle 7. Angle 7 is also going to be x because they are vertical angles. All right. Both angle 6 and angle 8 form a linear pair with angle x, which means that they are supplementary. Remember our linear pair theorem. According to our same side interior, angle x and angle 2 are also supplementary because they are same side interior angles. Okay, there are two parallel lines cut by a transverse, and they're same side interior angles. Okay. angle 1 and angle 2 are a linear pair, so they're a supplementary. So since x and 2 are supplementary and 1 and 2 are supplementary, that means 1 must be equal to x according to our congruence supplements theorem. And we'll get to that in a minute. Okay. So we have same side interior angle is supplementary. Then we have alternate interior angles, which we just recently talked about. If a transversal intersects two parallel lines that are if a transversal intersects two parallel lines, then the alternate interior angles are congruent. Okay, so again, if I have two parallel lines cut by a transverse, then angle 1 and angle 2 are congruent. So same side interior are supplementary, alternate interior are congruent angles. Okay, then we have the corresponding angles theorem. If I have two parallel lines cut by a transversal, like I have here, then angle 1 and angle 2, the corresponding angles are also congruent. So the alternate interior angles are congruent, the corresponding angles are congruent, and the alternate exterior angles are congruent. Okay, so alternate interior, alternate exterior, and corresponding angles are congruent if the two lines are parallel and cut by one transversal. They have to be on this one transversal. The same side interior angles are supplementary. Okay, so let's talk about how we can prove some of these theorems. Here, our theorems are just proofs, right? They're ideas that have been proven true. Okay, so it says prove the alternate interior angles theorem. Okay, so the alternate interior angles theorem says, okay, if I have two parallel lines, M and N are parallel, then that means that, and we got to prove that the alternate interior angles are congruent. We can't use the alternate interior angles theorem, so we have to go ahead and find a different way to show that angles 1 and angle 2 are congruent without using the alternate interior angles theorem, because we're trying to prove that the alternate interior angles theorem is true. So we'll start with the given. The given is that M is parallel to N. Okay, because that is the given in the actual theorem. Okay, so let's talk about angles 1 and angles 3. They are same side interior, so therefore angles 1 and angle 3 must be supplementary. Since they are supplementary, that means they must add up to 180 degrees. Notice that I put a little m here for measurement. Again, when we're talking about adding angles together numerically, you need to put the m for measurement in front, because we're talking about actual measurement of an angle. So, and measure of angle 2 plus the measure of angle 3 is also 180 degrees. They call it the angle addition postulate. You could call them a linear pair if you wanted to. But either way, they add up to 180 degrees. So since they both add to 180 degrees, that means that these two equations must be equal to one another due to the transitive property. And then you could subtract angle 3. So by the subtraction property, you subtract angle 3, and we get to the measurement of angle 1 is equal to the measurement of angle 2. Our goal is to prove that they're congruent. So we need one more step to go from measurement back to congruency. So angle 1 is congruent to angle 2. And ta-da, we have just proved that the alternate interior angles theorem is true. Let's do another example. So this is a little bit trickier. It says use diagram to prove the angle relationship. So we have AC is parallel to DF. and we have BE is parallel to, is perpendicular to DF. So that little symbol there means perpendicular. That symbol there means parallel. And angle AEB is congruent to angle CEB. And our goal is to prove that angle BAE is congruent to BCE. So let's see. We're going to start with the given. Okay, that's given to us. Okay, then we talk about that angle BED and BEF are right angles. Now you might think, well, they told us that. No, they told us that they're perpendicular. The lines are perpendicular, but the being perpendicular is implying that they create right angles. So you have to tell me, how do you know that they're right angles? Well, I know that because of the definition of perpendicular lines. Okay, so because they're right angles, that means that both measurements equal 90 degrees. Then when I add the two angles together, so I have angle AED and angle AEB, these two angles must add to 90, and these two angles must add to 90 due to the angle addition postulate. Okay, the book likes to throw sometimes use the other given in different areas. I like to put all of the givens first. Okay, so I would usually put this with the given up here, but they are stating it down here that angle AEB and CEB are congruent. So because they're congruent, that means that we already proved that these are complementary angles because they add 90. So then they use the congruent complements theorem to prove that AED and CEF are congruent. And then because I have parallel lines, I use the alternate interior angles theorem to prove that BAE is congruent to AED. And then finally, based off of the transitive property of congruence, I have, because BAE is congruent to AED and BCE is congruent to CEF, we already stated that CEF is congruent to AED. Because all the transitive properties, we confirmed that BAE is congruent to BCE. Now, I want to talk about proofs for a second. Not all proofs are created equal. What do I mean by that? Well, you might see it one way, and Billy Bob might see it a different way, right? So sometimes proofs can be 4 or 5 steps. Sometimes you can make them more complicated because you see it a different way. It's not that it's wrong if you take it a roundabout way to prove something. It's just sometimes there's an easier way to prove what you are proving. So if you solve this proof at the beginning of this video a different way, that's okay, right? Proofs are just showing me that you are able to think about these properties and postulates and be able to apply them to a problem. I wanted this. Here it is. All right. So overall, we have really 4 important postulates and theorems. Okay, we have the same side interior postulate, which says that if 2 parallel lines are cut by a transverse, that they are supplementary angles. And then the alternate interior angles, corresponding angles, and alternate exterior angles are all stating that they are congruent angles if I have 2 parallel lines cut by a transverse. Again, all of this only works if my lines are parallel. If my lines are not parallel, none of these theorems work because it's always the condition is always if the two lines are parallel. Okay, and we'll talk. We'll keep working with these. They're a little tricky, but we'll do a lot of practice with them today. All right. See you guys soon.